These are the four types of lines that you need to know. This is my horizontal line. As you can see, a vertical line up and down. This is what we call a positive slope because it's going up. Consider going uphill. Negative slope, it's going down. Consider going downhill. By the end of this video, you'll have a good understanding of all four of these lines and how to graph them. The symbol for slope is m. The equation for slope is y2 minus y1 over x2 minus x1, which is simply saying, let me find 2 points on the line. I'm going to subtract. I'm going to take the difference in the location of the points, and that's going to give me the slant of the line, or if it's slanted at all. As you can see here, it's not slanted at all. That's also called rise over run. Let's consider these 2 points, for example, and we want to know what's the slope of the line that connects these 2 points, these two ordered pairs, x comma y, x1, y1, x2, y2. We simply plug the values into the equation. But we have to do it carefully because if I found that if you try to rush through this, it looks so simple, but you're going to screw it up. You're going to get your slope wrong. If you get your slope wrong, you won't be able to find an equation of the line. So just take your time on this step. Locate y2, y1, x2, x1, 4 minus 2, 2, 3 minus 1 is 2. 2 divided by 2 is 1. The slope of this line is 1. The slope is positive, so it's going to be going up similarly to this one. There are 3 different forms of a line. The first one we're going to be looking at is the one that you see most often, the one that you're going to have to know the most. So pay close attention to this section. This is called the slope-intercept form of a line. And listen to what I'm saying. It contains a slope m and our intercept b. So its name directly relates to what it is, the slope and the intercept. The intercept is the point where our graph hits the y-axis. That is our intercept of the y-axis. That is the point x equals 0, y equals whatever point here be. In this case, if we look at it for this line, y equals 2x plus 1, we have a slope m, and my y-intercept is 1. So when I cover this up, how do I know what my y-intercept is? That means x is 0. That means this guy goes away. I can cover it up. My y-intercept is the point 0, comma 1. It's that easy. X equals 0. This guy goes away. Y equals 1. That's the point 0, comma 1. And as you can see with the positive slope, it's going up. We label it y equals 2x plus 1. When we're done, you label the line here or here generally. When you graph it, this is what we call a quick and dirty graph. You want to graph it quick. You don't need to spend a whole lot of time on it. When you're practicing and learning these, you want to go ahead and graph quickly. But you can see I've gotten pretty good at it. I did this by hand, but it doesn't really matter too much. You want to put in your values, and when you label your graph, you want your axes to be in reasonable numbers. 1, 2, 4, 5 are generally the numbers that I use. You can use different values for x and y. It's best if you use the same values for x and y, I found. You only have to label the side that you're going to be using. I'm not labeling over here. I'm not wasting time over here. I'm not even putting in those lines over there. You can plot this graph in 2 ways. We can use this rise over run to our advantage, or we can make a table. Let's look at the rise and run. It's a pretty nice way to graph a line really quick. This is quick too, but this is another quick way. I like the table, be honest. But let's look at rise and run. That means our change in y over our change in x? Well, if the slope is m, that means our change in y and over change in x is 2 over 1. It can be any ratio of 2 over 1. How does that work? I start at my y-intercept here, and I go, this is y goes up, x goes across. So I go, or if it was negative, y would go down, you know. But since it's positive, y goes up from 1. Up 2 is what? 3. To the right, 1 is here. So that's the point 3 comma 1. It lands on the line. I can take these 2 points and I can plot my line just like that. I went from here up 2 over 1 to the right. If it was negative, I'd be going maybe like up 2 and over this way. Either way, I could have gone down to same thing. One of the values would have to be negative. Now, I can also make a table. Generally, when I make a table, I only use 2 values. When you're starting out, you need to use 3 values. The reason why is because when you're starting out, you may have one value wrong. If you have one value wrong, you're going to plot the wrong line and you're going to get a lot of deductions on that. But if you have 3 values, if one value is wrong, you'll see it. It will sit out and then you'll be able to recalculate. So what you do is you draw up your table, boom, boom, x comma y. We pick our values based on the following. We take a look at our equation, see what values go in there easily. I like to keep my numbers low, super low. 1, 2, depending on what I need. In this case, I'm going to go with positive 1. 2 times 1 is 2 plus 1, 3. That gives me 1 comma 3. I'm going to stay low. I'm going to go with 0. That's always a popular choice. This goes away. 0 comma 1. I'm going to go with negative 1. I like to have the opposites here. Negative 2. 2 times 1. Negative 2 times negative 1. Negative 2 plus 1 is a negative 1. These now ordered pairs. 1 comma 3. 0 comma 1. Negative 1 comma negative 1. And we can plot those ordered pairs. You see, I have the points labeled on the graph. Negative 1 comma negative 1. 0 comma 1. Remember, that's our y-intercept. So that's real nice to have there. And then I have 1 comma 3. So the next table line we want to take a look at is a horizontal line. That's the side to side. It has no slope. Think about a flat ground. There's no slope on the flat ground. In this case, we're using the line y equals 2. Consider the equation y equals mx plus b, whereas y equals 0x plus b. Because there's no slope, slope is 0. There is a slope, but the slope is 0. I want you to remember this line. Just memorize it intuitively. Y equals 2. For all values of x, that has to be horizontal. To dig into it, let's look at the table. This will illustrate everything. If I pick any point for x, y equals 2, x equals 1, y equals 2, we're still staying low. X equals 0, y equals 2, x equals negative 1, y equals 2. All our ordered pairs, we can plot those. They'll be on this horizontal line. So you can see, if you wanted to illustrate it, take a look at it, that is, it's clear that it's a horizontal line. So even if you didn't know, plot your ordered pairs and then you'd be able to see it. One interesting point is that the point 0 comma 2, that is our y-intercept. Y equals 2, 0 comma 2. Interesting point. So what if you were given this equation and you had to graph it and put it in slope-intercept form? Slope-intercept form, y equals mx plus b. First, you'd write the equation down again. That's how you train. You write the equation every time. And we want to transform this into that. We have to move the x over, subtract x from both sides. That's going to give me y equals negative x plus 2. It's in the form of y equals mx plus b. We can quickly identify the slope in the y-intercept. We see the slope here. It's the coefficient of x, which is negative 1. Our intercept is out here. That's 2. You can use either method here. We're going to go through both. Rise over run. -1 is just like -1 over 1. So in this case, you'll see an illustration of going down from the point 0, comma, to our y-intercept, and then we go down 1, but still to the right 1. This point lands on a line. We could draw a line through those two points and we'll graph it. Once we drew up our quick and dirty grid, we put in, if we look at our equations, we see our numbers are pretty low. I'm going to go by 1, 0, 1, 0, and then I can graph it real quick. Then I label it. I always put 0 in for the origin. If I want to make a table, of course, I'm going to keep my values low. I'm going to start with 1. 1 works real well for this equation. I can see 1, -1 plus 2 is going to give me 1. I'll go with 0. I always like 0, as you see, helps keep the values low. 0 plus 2 is just going to be 0, a y-intercept. Then I'll go with a -1. Negative is positive. That gives me a +1 plus 2, +3. I can put parentheses around these if I want to identify them as ordered pairs, or just recognize that these are your ordered pairs, 1, x, comma, y. Once again, once you get good at this, you'll only have to pick 2 values, but in this case, I suggest picking at least 3 to guarantee that you plot the correct line. Next, let's take a look at this line, a vertical line, up and down. Intuitively, I want you to remember that it's vertical, so all the y values are changing, but the x values never change, so that's the line. In this case, we have the line x equals -2. As you can see, x values never change. The y values go for plus minus infinity. We can illustrate that in the table once again. Let x equal -2. Or in this case, we look at the y values. Let y equal 2, x equals -2. Let y equals 0, x equals -2. Let y equals -2, x equals -2. Let y equals whatever, x equals -2. So intuitively, it's going to take a second to figure the relationship between these two lines because it's counterintuitive, which means it goes against logic. So that covers slope-intercept form. And that's the form that you're going to see most of the time. General form is a nice tool to have. You won't see it too often, and a lot of people don't know that it exists. Now you know. It's ax plus by plus c equals 0. It's general form of a line. There are 3 forms. We have slope-intercept form, general form, and we have point-slope form. That are the 3 that you can use. It'll take you all the way through most of your math career, no, depending, if you can go a long ways with that, all the way to a bachelor's degree. Just those are the forms of the line that's going to be so critical. With general form, it'll never work if A and B are both 0. So if A is 0, B can't be. If B is 0, A can't be. Because if A, let's look at it, it's a simple fact. If A is 0 and B is 0, there is no line. There's nothing. So just remember that in a simple way. I don't want it to be complicated. It's not complicated. If A is 0 and B is 0, there's nothing there. Next, let's take a look at point-slope equation of a line. You won't see this as much as slope-intercept, but this is a useful tool to have. And if you know this, you'll know a lot more than a lot of other people, because a lot of other people don't even use this, but this is very useful. If I'm given a slope m and a point x comma y, then I can use this to write an equation of a line. And this is what it's all about, writing an equation of a line. We're going to write an equation of a line in slope-intercept form. We're going to write it in point-slope form and then in general form. But if you want to write it in a point-slope form, you have your slope m and a 1 point. Here we go. We have y minus y1 equals m, x minus x1, where x1 and y1 is the point that's given, and the slope m, we know what that is. We plug those in. We can see this. Let this be my y1. That's my x1. We solve this that's going to give us, we solve that by y minus 3, add 3 to both sides. That's going to give me, they cancel here, 3x. 3 minus 1, 2. It's in slope-intercept form here. So given the point and slope, we can generate this equation. We can also generate the general form of a line. Let's use this. We created this slope-intercept form. Now, let's put it in general form. ax plus by plus c equals 0. We want it just like this with all the values on the left side and 0 on the right. So we have to get it into that form. We have to bring everything over. Let's subtract 2 and subtract 3x from the right side. They cancel all out, and that gives me y minus 3x minus 2x. Excuse me, y minus 3x minus 2 equals 0. In general form, it's going to be a negative 3x plus y minus 2 equals 0. But we'd like to see either this will be correct, but it's better if you make this a positive. So we multiply through by a negative, change the sign on everything. That gives me a 3x minus y plus 2. I want this leading term to be positive. Equals 0. That's my general form of the line. We generated all of that from point slope form, given the slope m and the point 1 comma 3. Remember, if it's a slope m, this is a line that's going what direction? It's going upward because my slope is positive. We're not going to graph it, but we do know it's a line that is climbing. Using what we've learned, we could also find, we could take this line and find a parallel line to that based on what we've learned. If the line is parallel, you can see visually that they have the same slope. That is m1, the slope of the line that we start with, and the slope of the line that we create, and the next step is going to be the same. So now let's take our knowledge of lines to the next level and find a parallel line to this line, y equals 2x plus 3. Here's the solution. So here's the illustration. We know that y equals mx plus b, but we also know our parallel line has what type of slope? An equal slope. We can use that fact to find a line that's parallel to this line and goes through the point 0, 1. Remember, there are infinite many lines that are parallel to this line, but we want the specific line that goes through the point 0, 1 that has a y-intercept of 0, 1. So we have the slope. We see the slope is 2. We can plug these values into this equation and it'll solve it for b. So y equals 1, 2 times 0, x equals 0 for this x comma y equals plus b. So b equals 1. So now we can rewrite our second equation is y equals same slope times x plus our y-intercept b. So our second equation is going to be y equals 2x plus 1. That is the parallel line to this line going through the point 0, 1. So let's take it one step further. We can use what we've learned to find a perpendicular line. Let's find a perpendicular line to this line, y equals 3x plus 1. This line is perpendicular to the line y equals 3x plus 1. When it's perpendicular, this forms a right angle. Given that this forms a right angle, the slope of the first line in relation to the slope of the second line, that is, the slope of the second line equals -1 over the slope of the first line. Sounds like a lot, but we're going to go over it. Similarly to the parallel example, we want to find a line that is perpendicular to this line, but it goes to the point 2, 9. I picked these values for a reason because I'm going to have a 1/3 and I just want to cancel that out. That's why I picked the point 2, 9. So here we have it. M2 The slope of the second line is going to be -1 over the slope of the first line. And as we can see here, forms the right angle. Here's the line that we had illustrated on the whiteboard. And here's our new line. And here's the point 2, 9. Just a general, this is not to scale. But we're going to use the same concept that we use here. And this is the value of the slope-intercept form of an equation we have. We want a line that's, once again, that's perpendicular to the line, 3x plus 1, and going through the point of, actually, 9 comma 2. I think I said 2 comma 9, but this is through the point of 9 comma 2. Okay, so y equals mx plus b. We know that we have to calculate the slope. In this case, it's not the same. It's -1 over the slope, so that's going to be -1 over 3. We have a slope of the new line is going to be a -1/3. So y equals a -1/3 x plus b. We have to just calculate b based on this point. We plug it in. Y1 equals 2, x1 equals 9. So nice and neat. We see y equals 2 equals a -1/3 times 9 plus b. -1/3 times 9 is a -3. I'm going to add 3 to both sides. These cancel. B equals 3 plus 2, 5. We go up here, b equals 5. So now we can write our new equation. Y equals -1/3 x plus b plus 5. That's going to be perpendicular. That's going to be this line, perpendicular to that line. So let's wrap it up and put a bow on it. Here's what we learned. These are the 4 types of lines that you're going to run into. A horizontal line, side to side, no slope. Vertical line, infinite slope. Line going up, it's a positive slope. Going down, negative slope. Equation for slope here, y2 minus y1 over x2 minus x1, also known as rise and run. Given 2 points, I can find the slope here. I find that, be careful when I do it. Slope-intercept form of equation. We're graphing here, quick and dirty. 3 values here. I can use rise over run. Just put that, if it's a whole number, I put it over 1. And then I can go from here, from the slope, from the y-intercept, and go this guy up or down, and this guy to the right or left, depending if positive or negative. And so this is our horizontal line. We took a look at the horizontal line, and we were able to illustrate, write out why it was horizontal. Our negative slope, we were able to apply those same rules to that. Our vertical line, our up and down line, we use the same rules to visually explain why this line is vertical. But with our horizontal and vertical lines, I want you to remember that y equals 2 is always at 2. So that's going sideways. And x equals whatever value is always at that value. So it's going to be going up and down. The x's never change. So you know the x never change. That means the y must change. And so it's going up and down. We have our general form of a line, ax plus by plus c equals 0. We know a and b cannot be 0 because there would be no line. Then we learned point slope form of a line, which is a great tool to have. Our second form of a line, we went through that point slope. We took a point in the slope and we were able to generate slope-intercept form of a line and the general form of a line. Next, we looked at our parallel lines. We knew the slopes were the same. Armed with those tools, we were able to take our skills to the next level and find a parallel line to a given line. Going through a specific point, we did that using slope-intercept form of a line. We plugged in the slope and this point to find B, and that gave us our new line. That was our parallel line. And our parallel line, as we know, has the same slope, 2, 2. And in our final step, we took a look at our perpendicular line. The slope here, a little more complicated. the slope of the new line is going to be negative 1 over the first line because they make a right angle. We use the same method here. We plug in the slope and then we plug in the point. In this case, we use this point. We plug in the slope after we calculated it to be negative 1 over the other one. And you can see 3. So we calculated it to be a negative 1/3. Plugged in that value. Out it came. Certainly, that's not everything you need to know about the lines and graphing them, but hopefully that's the essentials. I think with that information, you should be able to go a long ways. I hope that was helpful to you.